Hello, today we're going to cover College Algebra 2.4 and everyone's favorite word problems. So we start off with systems of equations. Now there's a few different ways that you can solve a system of equation. You've probably seen these once at somewhere in your life. Substitution, elimination, and then we could solve it graphically, or we could use our handy dandy calculator and use matrices. So keep your calculator handy and I will show you the easiest way. So real quick, just to appreciate its easiness, let's cover this problem here in a couple of different ways. So substitution is generally kind of the go-to. Usually when people see it, it makes the most sense. They kind of go for it. So to solve this problem with substitution, I would take either one of the two equations and solve it for one variable. So for example, if I chose substitution and chose the top equation and chose the top equation to be solved for x, then I would add y to both sides to see that the x equals positive y plus 5. Because remember, adding it to the other side would cancel it on the left, therefore making it be a positive y plus 5 on the right. I would then substitute this equation in for the variable x of the second equation. It's saying that x and the value of y plus 5 more are interchangeable. So the value of x, the mystery number x, is 5 higher than whatever the mystery number y is. So we're going to use that and replace this x right here. So I'm going to rewrite this equation to x plus y equals 1. But in place of the variable x, I'm going to substitute y plus 5. Now, just like any other problem, I'm going to distribute and solve it for the variable y. This, of course, would give me 2y plus 10 plus this y over here. Remember to combine your like terms. Don't try to subtract y both from the same side. And then I move my numbers. And last I divide to get y all by himself. Oops, sorry. Finally, to see that y equals negative 3. Always watch those signs. So this is only half of our solution. If I needed the system of equations, I need both of the points, x and y, both of the values, to see how I could find this solution. What point on the graph would make this true? So I continue the problem by resubstituting this known value of y now for either one of these two, because they should both meet in the same point. So if I happen to choose the top one, x minus y equals 5, and now replace that value of y with this value I've discovered, that y should be equal to negative 3 to make this work out, then x minus a minus 3 equals 5. Remember that double negative becomes a positive, so that really means that x plus 3 is 5. Which, if you subtract the 3 from both sides, means that the x would need to be a positive 2. So I rushed through this just a little bit because this isn't really going to be the way I recommend you solve these. So don't worry if you're not quite on the same page just yet. Now reworking the same problem, starting back over, pretending that I don't know the solution now is 2 comma negative 3. Let's think about the other way to solve it with the elimination. So if I copy the problem over, let me just rewrite it. Okay. The x minus y and the 2x plus y. Another way to solve this system of equations is to eliminate one of the variables. Now in this problem, it's actually set up really well for an elimination because this one has a negative y and this one has a positive y. But just so you can see that even if it wasn't that easy, it would still work out. I'm going to do it the harder way. Now this top equation has one positive x. The bottom one has 2 positive x's. If I wanted to eliminate one of the x's and make them kind of match, usually we use integers instead of fractions. So I would multiply the top equation left and right by the value -2. That's going to change the top equation into -2x plus 2y equals -10. So notice that I've distributed this -2 to each one of these three members. This one, and this one. I'm going to copy down the bottom equation exactly the same as it was. And now I'm going to eliminate those x's by adding the equations as a whole. So just like if I'd been combining like terms. So -2x and +2x cancel, just like I wanted them to. +2y plus another y would make it 3y. And -10 plus 1 makes -9. Kind of looks familiar, right? So in that last step, when I divide by 3, we do end up with the same answer as before, which makes sense. We were expecting it. So this would give me the value that y, of course, is -3, which then, just like the last one, we would usually do a substitution at that point, sub it back into either one of those two to find the given corresponding x of 2. So these are two methods. Another method is graphing, where I would just literally graph the two lines. Now that one is a little bit sneaky because if we're using our TI calculators, we have to get it in y equals form, which means I would need to kind of manipulate this equation to solve it for y, then plug it into the calculator. And then it would really only be helpful if the answer was integers like this right here. So if I had an answer of like 2.78942, that would be really hard to see visually on the calculator. And even if I use some of the calculator features, I'm still going to have a limitation to the rounding that it does. So that's why I never even really go to the graphing. It's just pretty limited. It's the least cool. So these are the more precise methods. Substitution, like I said, tends to be people's favorite, but the elimination can work out really nicely, especially in this case where, like I said, we were already set up to have one variable be eliminated. Now in these last two right here, we're going to go one more time, kind of over these methods. So this one, if I wanted to do that substitution again, I could solve it pretty easily for x by adding the 3y to both sides. So I would see that the corresponding equation would be that x equals 3y plus 1. Again, he's positive because I'd have to add him to the other side. I would then substitute that in place of the x of the second one. So notice I just put a big kind of bubble right there where the x was. And then I'm going to fill in that bubble with his substitution, 3y plus 1. And then work it out like normal. Now this one's going to do something funny, so keep an eye on it. This right here is one of the few rare special cases. Most of the time, probably 97% of the time, they work out like this. Now this happens because graphically, these would have two completely different lines that would cross each other in one single point x, y. So that the only point that would be on both of those lines is the point 2, -3. Now this one, as we work it out, I see that weird thing happen where these cancel. It's kind of like the problem we saw in the earlier chapter where we got the no solution. It's kind of like a no solution. -2, of course, does not equal 5. So this would be this special case of parallel lines. Parallel lines are inconsistent. Consistent means we got an answer. There was a point where both of the conditions were fulfilled. This one would not have any point that could make this line and this line work out. There is no point xy that would be on both this top line and this bottom line. So this one is inconsistent. Now here's the other one special case. And again, remember it is a special case. So most of the time it's like this guy. So if I wanted to practice my elimination again, like this where I was making something eliminate, I see, okay, here's a +4, here's a +2. So let's again multiply by a -2, because that will make these match. That would make the top equation be -4x minus 6y equals -12. And then just rewriting the bottom equation, we start to see something fishy's going on because I was trying to make the x's cancel. I did that, but unlike this one over here, the y's also canceled. So basically I had nothing left on the left. Well, on the right, let's see if it's inconsistent like the last one, but negative 12 plus 12 is also 0, the same 0. So this is the other special case. This one is the dependent case. This occurs in the 2D world, Cartesian coordinates, when I actually had the same line twice. So they had some sort of different multiplier to make them look different, but I actually was dealing with the same exact set of numbers, x, y, the same ordered pairs. So they formed the same line. So they are consistent. They have a solution. In fact, they have infinite solutions, but they are dependent on each other because one is completely identical to the other. So these other two, we had two independent lines. They were different. They had points that were apart from each other. This one was inconsistent because they never crossed to find a point xy on both lines. This one was dependent because it was the exact same line both times. Inconsistent for basically a no solution, dependent for those all real numbers kind of case, to compare it to our earlier lesson. So all of that to say, we really don't need to do any of this because once we take things up a degree, things get infinitely more complicated. Not really infinitely, but a lot. Because these 2D cases, we only had one solution, no solutions, or infinite solutions. If you add just one more dimension, things get crazy. We could have the one solution, which is our favorite, where the 3D planes all connected in one single nice pretty dot. But any of these other things could have happened. They could have kind of formed this 3D triangle where any two planes would cross each other, but there was never a point where all three came together. They could have all been completely parallel where nobody crossed anybody. It could have been that same kind of line on top of itself where it was one single plane just with different multiples. Or it could be kind of like a book spread out like this where all three planes met together with infinitely many solutions on a line. So because of that, lots going on here, and the fact that you would have to solve it with substitution or elimination in all of these stages, this is actually a very precise way to solve it. This is about as short and neat as you could do it. You can see it's pretty complex. I recommend your calculator. So grabbing your calculator, let's learn how to solve these problems without any of this. We're going to use the Matrices function on the calculator. It's not a special program. You don't have to get the programs from me. It's just automatically built into that TI 83 or 84 calculator. So the first thing we need to do is to learn how to talk to our calculator. It's going to ask us about the order of the matrix. Now this always seems a little bit backwards to me because I think x, y on the Cartesian coordinate, the order of the matrix is a little bit backwards. So we do rows, columns. So reverse out of alphabetical order, row by column. So this one would have an order of 4 by 2, 4 rows, 2 columns. This one would have an order of 2 by 5, 2 rows, 5 columns. So like I said, a little bit backwards, reverse of alphabetical order, and not left, right, up, down like you would with the ordered pair. So in this one right here, if I wanted to communicate with my calculator and put it in, I would put it in as a 3 by 4 matrix. Okay, now it would need me to fill in all of these positions, even the ones that were blank. So I do that by writing it in as just the coefficients, no letters at all. So remember the ninja numbers, the coefficient of this x right here would just be the understood 1 in front of it. There is 1x. There are negative 8 y's, positive 6 z's, and then that is equal to negative 6. So again, notice there are no x's and y's. Because of that, it's incredibly important to be neat and clear. So since I put it as x, y, z, I have to be consistent. The next line has to be x, y, z, or the whole thing falls apart. Next, I've got 8 x's, minus 5y's and another 6z's, watch those signs, equal to 4. This is the one I mentioned. We have to be consistent. So right here, this is the x's. In the third line, there are 0 x's. I put a 0 as that placeholder. 7y's, negative 1z's, be careful, equal to negative 5. Now for our human brains only, just to kind of understand, we put this straight line right here for human eyes to indicate that these were the variables, this was the equal sign, and this was the solution. In the calculator, we won't put that line. It's just for humans. Okay, so that's a human line for our human eyes. So right there, don't put it in the calculator. So now let's interpret, because once we tell it what we need in computer speak, it's going to give us the answer in computer speak. So let's go see if we can figure out what that means. So if it told us this, and remember, it would never show us this line. It's just for us. This is because a human made this for us. It would tell me they were actually saying that there was 1x, positive 5y's, negative 7z's, equal to 6. So be careful, don't write 1x, 5y, negative 7z. There's pluses and minuses between each of these terms. This one, that 0 is the placeholder. So this one has 0 x's. It starts in with the 7y's. I could put 0x, but it's not fully simplified. So let's just start with the y's. The last line, I've got 7 x's, but then it skips the y's and goes straight to the z's. So if I wanted to put this right here, the system of equations, into my calculator, into the matrices form, I would use those coefficients, 2, 4, negative 6, negative 2, positive 2, and 12. Remember, I'm not going to put the line because that's just for us, into my matrix. All right, here we go. Here's the steps. It seems like a lot the first time, but it's really in 3 stages. So just kind of keep it in stages in your mind. So I'm going to go into the matrix. So I use my second button, and then right down here, this one says matrix in blue. So I do my second matrix. Okay, then it gives me all of the matrices option. In my first stage, I'm going to arrow over to edit. First time I'm going to edit a matrix. When I hit enter, it gives me the option for whatever order of matrix I want. This one has 2 rows by 3 columns. So I do 2, enter, 3, enter. And then you should see kind of a setup for a 2 by 3 matrix. Hit enter one more time, and you can start entering in the values. So I hit 2, enter, 4, enter, negative 6, enter, making sure to use the little negative down here, not the one on the side. And when I hit enter, after that negative 6, it automatically takes me to the next line. So I go negative 2, enter, 2, enter, 12, enter. And it should look just like you have on the screen. If it doesn't, go back and double check that. Now here's the most important part. After you hit the 12, enter, make sure that you do a second quit. I forget this step half the time and it messes me up. So right here, before you go to the next step, you have to get off of the screen and go back to your regular home screen. So don't forget to second quit. Okay, if you ever forget it, it's super obvious and you can just go back a step. Next, we're going to go into the matrix again for the second time. Okay, so all of that was step 1. This is step 2, second matrix. This time we go to math. Arrow over to that second option. Don't hit enter yet. It has lots of different math things we can use, but I need a certain one. So I scroll down, keep going, keep going. We want the one that is RREF. So be careful, there is an REF, but we want RREF. So not RUF, we want RREF. So make sure you're doing RREF right here. So it stands for row reduced echelon form, but don't worry, I'm not going to have a vocab quiz. RREF. Okay, so after you select that It should put it back on your blank home screen. So like I said, if you forgot to second quit, you'd see it in the matrix and you know something was up. So he's on your blank home screen waiting for you to do the third and final step. So one last time, second matrix. And then if you put it into matrix A, you want it to re-roof matrix A. So I hit enter, enter. And there it is. So first time we put the matrix in, we did edit. Second time we selected re-roof. And then third time we told it to re-roof our matrix. 3 stages. So it told us our answer in weird calculator speak, matrices form. But remember, just like we did up here, we can interpret this. So this was really saying that we had 1x and 0 y's equal to -5, 0 x's and 1 y equal to 1. So that means this was really x is -5. And this one was really y is 1. And that's our answer. We're all done. Now it seems like a lot the first time, but it's way better than all of this, I promise. So let's try it with a bigger one. Here we go. And change colors. Let's put it in our matrix form. 1x, -2 y's, 3 z's equal to 11. 4x, 2y, -3z equal to 4. Always watch those signs. 3x, 3y, -1z, and 4. No zeros, no placeholders this time. Here we go on our calculator. Second matrix edit. This time it's a 3 by 4. 3 rows, 4 columns. Enter in all those numbers, making sure to use the little negative on the bottom. And then after you get in that final 4, don't forget to second quit. Don't forget to second quit. Okay, now we go second matrix for the second time. Over to math, don't hit enter yet. Scroll down to re-roof. Last time, second matrix, enter, enter, and there it is. Row reduced echelon form gives us the answer 100, 010, 001, and 3, -1, 2. So that means the answer to all of this was really the point on the 3D graph with an x of 3, a y of -1, and a z of 2. Sorry, clean that up a little bit. At that point, all 3 of these planes would meet. X, y, and z. So we can try it one more time right here. With this one, you will see that you get an answer that is a fraction, but that's okay, because as always, you can do that math, enter, enter. So this one does have a placeholder, so just be careful when you're entering it into the matrix, that you do it as the 2, -1, 4, 3, -3, 1, -2, -10, -6, 3, 0. The y's were missing in that last row, and 7. When you give that a try, you should get the solution where your x is 3, your y is 7, and your z is -1/2. So it makes everything much easier. And that helps us out when we switch into word problems. Now again, remember the first step of a word problem is don't panic, okay? You know it's gonna be like the stuff you were just covering, so we'll probably get to use our matrices. We're gonna involve more than one variable in most of these, but we just need to read it out, not panicking, and line out our thoughts. Sometimes it helps to draw a picture, you know, just organize your thoughts in whatever way. So at Max's Munchie, he's selling 2 different snacks, caramel corn and honey roasted mixed nuts. They have different prices. Somebody's coming in for a mix of the 2, and they wanted to average out at $4.50 per pound. So we have two different things we're thinking about. We of course have the two snacks, but of the snacks, we're thinking about both their weight and their value, the cost to buy them. So we're going to assign some variables. So after our step of not panicking and after our step of reading, I need to assign the variables. Don't skim past this part because you'll get deep into the problem, find the answer, but then not remember which one was X. So don't do that. So right there at the very beginning, even if it's an abbreviated form, tell yourself which is which. I'm going to let X be the caramel corn and Y be the honey roasted mixed nuts. You can use whatever letters you want, but make sure somewhere up at the top you tell yourself what is what. Now in this one, we're going to end up with some matrices. Okay, I know this of course because I've worked this a few times, but watch as we go kind of how I organize things down here. So like I said, we've got money and we've got weight. We know in the end they're hoping to make a 20-pound mixture. So it's going to be 20 pounds total, where some of it is caramel corn and some of it is honey roasted mixed nuts. So let's let X not just be the caramel corn, but the caramel corn's weight. Okay, so the pounds of caramel corn. Okay. So if I wanted to walk out of that store with a 20-pound bag, then that means some of it of X and some of it of Y put together should make 20 pounds total. Next, the question is, how much did I spend? So it said that they were going to charge me $2.50 for each one of those pounds of caramel corn. Well, if I bought 1 pound, I'd have a bill of $2.50. If I bought 2 pounds, I'd have a bill of $5. 3 pounds would be $7.50. Each time I buy another pound, I add on another $2.50, or I could take the pounds that I bought times $2.50. So that means each time I bought 1 more pound, I would get charged another $2.50. So the amount of pounds of X times $2.50. The honey roasted mixed nuts were more pricey. They charged me $7.50 for each pound of honey roasted mixed nuts. Now be careful, there's a trick in this one. I'm not walking out of that store with a $4.50 bill. I wanted 20 pounds that averaged $4.50 per pound. So that means my total bill is going to be not $4.50, but 20 times $4.50. So that means my total bill is going to be $90. Okay, well look right here. It's already in our nice matrices form, but I'm going to have kind of a box of neatness over here to the side. Once I've kind of scribbled down some notes and jotted down my thoughts and organized things, I was pretty organized because, like I said, I've done this problem, but you might have needed to scribble a few more little pieces of information. That's fine. Get as messy as you need, but leave yourself a little box of neatness where you can come put the important stuff in the end. So I've got that the X plus Y is 20. I've got that let's just shorten this to 2.5X and 7.5Y equals 90. 90 because 20 times 450. Now I can put that in that matrices form just like we practiced. 120. Don't worry, it works with decimals just as well. 2.5, 7.5, 90. Punch that in, do your math inner. Actually, you won't even have to do that. It'll be integers. Do your roof. And it should give you a matrix that looks like this, where you have 12 and 8. Double check. Yep. So here's where, like I was saying, if we didn't label things, it could be very confusing. So this tells me that the X was the 12, which means that the caramel corn would have been 12 pounds. So right here, I bought 12 pounds of caramel corn. and 8 pounds of honey roasted mixed nuts. And I could double check things. So of course 12 pounds plus 8 pounds would make 20. And I could go figure out my bill real quick by 12 times 250, 8 times 750, make sure I have a total bill of 90. So you can see how easy it would have been to get the two flip-flop to be confused if I hadn't labeled things up here at the beginning. Okay, here's another one. It seems like it's completely different, but it's really the same problem. Here we've got some drinks, and they're telling us different things about them. We've got servings of drinks, but then it does go back and tell us that all of those servings have the same ounces. Since they're all the same, I don't really need to figure that in. It's just an extra number to kind of try to throw us. So instead, we're dealing with the servings of the drinks and the amount of caffeine. So it says if we have 1 serving of each, coffee, energy drink, and soda, we have a total amount of caffeine. Let's set some variables. If I let X be the coffee, Y be a serving of energy drink, we'll abbreviate here, and then Z be a serving of soda. Then this statement right here said if I had 1 coffee and 1 energy drink and 1 soda, I would have had 201 milligrams of caffeine, and I would be pretty shaky. Probably shouldn't do that. Okay, here's my next bit of information. 1 serving of coffee has 7 milligrams more caffeine than 2 servings of soda. Don't panic, we got this. 1 serving of coffee was X, is, equals 7 more than 2 sodas. So if a soda had 1 milligram, then the coffee would have 9. Okay, 7 more than 2 of these. Okay, last it says that 1 serving of energy drink has 35 less than, here's that sneaky word I always said to watch out for, 35 less than a coffee and a soda. Okay, let's take it step at a time. 1 energy drink, Y, contains, is, equals, 1 energy drink equals 35 less than. That means 35's in the backwards. 35 less than 1 coffee, 1 soda. 1 coffee, 1 soda. Okay, now I've pieced together my information. Now somewhere off to the side, my box of neatness, let's organize our thoughts. Okay, this one's already a nice, neat form I can use for my matrices. But these are a bit jumbled together. For it to work for the matrices, they all have to be nice and neat and organized, just like this, right? All my X's together, Y's together, Z's together equals the numbers. So I'm gonna have to do a little bit of rearranging. So back down here, I've got my variables on both sides. I'm going to try to scoot those around. So this one I'm going to subtract the 2Z so that I can have them together. So this statement would be the same as X minus 2Z is equal to 7. So I'm going to put that in my matrix form. Notice that I don't have a Y, so there'd basically be a 0 there. Last, they're all mixed together again, so I'm gonna have to rearrange some things. I could go either direction. I personally would move my X and Z over like this. So that would rewrite this statement to be, I'm gonna put them in order, negative X plus Y minus Z equals negative 35. Careful not to lose that negative there. Okay. Now everything's nice and neat and lined up. So now I can use my matrices. So I can put it in the matrix form. I've got 1, 1, 1, 2, 0, 1. I've got 1, 0, negative 2, and 7. I've got negative 1, 1, negative 1, negative 35. And then I'll go in and do that roof, and it will spit out a nice pretty matrix that will look like this. Okay, find my numbers real quick. And we'll have an 81, an 83, and a 37. So again, this is why it's so important to label them in the beginning. This one was my X, which was the coffee. This one was the Y, which was the energy drink. And then this one was the soda. So I'm curious how true this is. I wouldn't have thought that coffee would be that close to the level of caffeine in an energy drink. So I wonder if they just use these numbers for a problem or if that's true. Okay, this next one, I've got a rectangle. Hopefully you guys remember what those look like. The kind of longish square. So it says that the length of a rectangle is 2 meters less than 3 times the width, lengths and widths, and it says the perimeter is 20 meters. So some refresher on words, remember perimeter is all 4 sides going around the edges like you were building a fence. So if I said that this was the width and this was the length, and to find the total perimeter, I would need to add all 4 of those together, width plus width plus length, which is generally written in the form 2 lengths and 2 widths. Because I would end up with 2 of each of them. Now this first statement here is written just like that energy drink one. So it says the length of a rectangle is equals 2 less than, it's their favorite trick, watch out, it means it's at the back, 3 times the width. There you go. Just always watch for than, from and than. Next it says the perimeter is 20. Well, that means that 2L plus 2W equals 20. Okay, now I could use my matrices. I could do substitution. This one actually wouldn't be too bad to do substitution because this is already solved for L. So if you're pretty comfortable with your algebra, that actually might be quicker than punching all the buttons on the calculator. So just know that that's an option. If you did want to do your matrix just to practice, remember to subtract your 3W over. So that means you would have 1L, but then you would minus 3W equals to negative 2. And then you would have 2 lengths and 2 widths equal to 20. So you have that option. Like I was saying, if you did want to substitute, we could do it that way and say that 2L plus 2W equals 20. Let's just work through that real quick so we have a little bit of practice in. So we replace the L with that 3W minus 2, distribute, combine our like terms, and then solve for W. And then 24 divided by 8 luckily gives us a nice pretty 3. Always keep an eye on the problem. Make sure you are fully answering it. In this problem, it asked us to find the width only. So we're done. It could have asked us to find the length as well. If it did, I could have solved it by putting that width that I just found back into my length formula, which would have given me 24 minus 2 would be 22. Theoretically, they could have asked me to find the perimeter, in which case I would have done my 2 lengths plus my 2 widths to see what the full perimeter would be. So even though you have a number, you circled it, just be careful that you did fully answer their question. This one looks like it might be the same. I've got another shape one. It tells me I've got a garden that's a square, but I had some critters eating my stuff, so I made a fence, and I put a nice pretty sidewalk on my fence, between my fence and my garden, so I could get around and do all my garden stuff. So I ended up building two fences, once around the garden and once around my nice pretty sidewalk. So I ended up with these two squares. It says that the garden itself, the inside, was a square with a perimeter of 60, so all the way around was 60. And then it says I built my fence with a 3-foot walking path. Okay, so if this square had all the same sides, of course, was 60 all the way around with those 4 sides, then any one of those sides must have been 15, because 60 divided by 4 is 15. 4 sides. Well, if I put a 3-foot sidewalk on it, then this one would be, careful, not 18, because I needed a sidewalk here and a sidewalk here. So not 18, but 21. So the full length of this fence would be 21. And of course, it's another square. So it asked me about that fencing. It says I need to build both of the fences, and the cost of the fencing was this right here. So first off, let's just see how much fencing I would need. So of course, I have the 4 sides of the smaller fence, which we already knew from the problem was 60. But I also needed to build my bigger fence with a side of 21, which would give me 84, which means I would need a total of 144 feet of fencing. I'm not quite done because I needed to pay for that. So if each one of those 144 feet of fencing cost me $1.14, then my total bill at the end of the day would be, turn the page, $164.16. So this one, we didn't need the matrices at all. There wasn't really any substitution. We just kind of reasoned through it. So even when it seemed like they'd be just the same, it ended up being quite different. Got to think through it, remembering to not panic. Here we've got a triangle, new shape, don't panic, you know this. He's that guy with the 3 sides. It even specifies that it is a right triangle. So remember, that's the one that forms a right angle. It says the lengths of the 3 sides are given by 3 consecutive integers. So this is a fancy word for one after the other. So like if I had 67, the next one would be 68, and the next one would be 69, one after the other. So I know that whatever these are, they're one after the other, but I don't know where they start. But since I know they're one after the other, I'm going to pick the smallest side to start with. Let me draw it a little bit more distinct, just so we can tell that it's smaller. It's a right triangle. So if I said he's the smallest, I'm going to make him X. Okay, because I want to. Then the next one is the next consecutive integer, so he is 1 higher. So 1 higher than any random number would be 1 higher. So if this had been 67, 67 plus 1 is 68, 1 higher. The next one is 1 higher than that, and of course 1 plus 1 is 2. So my 3 sides would be x, x plus 1, and x plus 2. 3 consecutive integers. Now it wants me to find the lengths of the sides. It doesn't seem like I have enough information. Here's the key. It was a right triangle. So there was a special formula that handled the sides of a right triangle. It had to do with that guy, Pythagoras. So he told us that he did a whole bunch of homework and found the pattern that said that a squared plus b squared always ended up being equal to c squared. So that meant the sum of the squares of the 2 shorter sides was always equal to the square of the longer side. So where this would be an a and a b, interchangeable as long as they're the shorter, and c was always the longest one across from the right angle. So if we said that one shorter side was x, and one shorter side was x plus 1, and the longest side was the x plus 2, then we're halfway there. Be careful not to make that kitten killing mistake. It's not x squared plus 4. We've got a FOIL. So remember that this is really x plus 1 and x plus 1. And this one is really x plus 2 and x plus 2. You've got to FOIL it. It's not just x squared plus 4. Okay, so it's a little bit longer than we might have liked, but it's all right. We'll make it through. Okay, so then that would give me an x squared plus x plus 1. Be careful, it's tempting to say 2. 1 times 1 is 1. X squared plus 2x plus 2x plus 4. Okay, so I can clean things up, combine my like terms, but also I'm seeing that I have some quadratics. Remember, the easiest way to solve a quadratic was to use that quad program by getting it equal to 0. So to get it to be equal to 0, I would want to move everything to one side. I could go either direction, but I like to go to the left. So I cancel these out by putting them over here. To get that, x squared minus 2x minus 3 is equal to 0. 1 minus 4 was 3, 2 minus 4 was negative 2. Now I can use that quad program. As always, it is going to give me the 2 answers, because it's always 2. But once I find those 2 answers, you'll see that something's fishy about one of them. So I punch it in with my a of 1, my b of negative 2, my c of negative 3. It tells me that the x's could either be 3 or negative 1. But remember, like I was saying, always make sure you've answered the question. These were the lengths of a triangle. So I probably can't find a triangle that has a length of negative 1. So he's out. So this is the only one that really makes sense. Now, I'm not quite done. I found that x is 3. So that means that the next bigger side would have been the 4. And last, the longest side would have been a 5. 3 consecutive integers. Okay, just a little bit more. Let's try this one with some bicycles. So I know it kind of seems like the 2-train problem, but don't worry, it's not as bad. We have these cyclists. We deal with their distance and their speed. So keep in mind that rate times time equals distance. Okay, they leave from an intersection at the same time. One travels due north, one travels due east. Okay, the guy going north going 18, the guy going east is 24, a little bit faster. They go for the same amount of time, and then it wants to know at what point is the distance between them as the crow flies 180 miles. So be careful, we have 2 different units going on here. This is a distance, these 2 are speeds. So since they are speeds, they are rates. 24 and the 18 are a rate. The 180 is a distance. I have to be careful. But I can connect the 2 with the variable of time. In fact, that's really what they're asking me about. How long? What is the time? So if I name my variable of time t, because it's a classic, then rate times time equals distance. If he was going 24 miles an hour and he traveled for 1 hour, he would have gone 24 miles. If he traveled for 2 hours, he would have gone 48 miles. This guy up here was going 18 miles an hour. So multiply that times however long he traveled, and we'd see his distance. So rate times time is distance, rate times time is distance. This one was already distance. Now they match, they're all distances. So now I have another right triangle. It's really the same as the last problem. So the 2 shorter sides, a squared plus b squared equals the longer side, 180 squared. And be careful, he didn't have the t, he was a distance, not a rate. So these numbers get a little big, but don't worry, we've got our calculator to take care of it. So this turns into 324 t squared. This one is 576 t squared. And this one is 32,400. And I add those up, it's getting a little prettier. It becomes 900. And here I have those options just like a few lessons ago. I could get it equal to 0 and use quad. I could use my square root principle and see if I could do my plus or minus, whichever way you prefer. It's kind of tempting just to try to isolate the variable. Most people end up doing that, which does give me 36. Just be careful in that last step, because when I square root both sides, technically there's a plus or minus. So t could equal 6 or t could equal -6. But unless Marty McFly is on one of those bicycles, probably the answer for this problem is going to be that +6. So mathematically -6 would work, but in the context of the problem, the answer of 6 is the only possible answer. This one is out. All right, one more in this section. I know this one's a bit long. We've got an inheritance. This would be a nice problem to have, right? How to split up your $15,000. So he's got these options in the money market, municipal bonds, and mutual funds. And he's got interest involved, of course, and just some statements about how things compared. So let's name our variables. We've got the money market. Let's call him X. And the money market is earning 4%. Just to organize our thoughts. We've got Y, the municipal bonds, and it says they are earning 5%. And then last, it's got the mutual fund, and it's earning 6%. Why don't just throw it all in the 6%? I don't know, diversification, something. We'll have to talk to a lawyer, right? Okay, so let's just do the math instead. So he's got 15,000 to split up total. So if X is the money in the money market, so this is how much he's putting here, how much he's putting there, how much he's putting there, then 15,000 is the total money of all three accounts. That means that sum of X, sum of Y, and sum of Z should total 15,000. Okay. It says 1 year later, he gets a check for $730 in interest from these accounts. Well, remember, the interest was earned, but with these rates based on the amounts he put in. So for example, if he put $100 into the money market at 4%, he would get a check for $4, because $100 times 4% as a decimal equals $100. Sorry, would equal $4. So that means I could figure the interest on any amount in the money market by multiplying it by 4% as a decimal. Same thing for the bonds. And same thing for the mutual funds as a decimal. At the end of the year, all three of those together gave him a check of $730. That would be nice. Last, it says there was $2,000 more invested in the mutual funds than there was in the bonds. So, seems tricky. Think this through. Which one is bigger? 2,000 more in the funds than the bonds. 2,000 more in the funds than the bonds. So the funds is bigger, right? Okay, keep that in mind, because it'd be easy to flip it the way it's worded, but you know, if you read that this one is bigger. So that means if the funds is bigger, Z is bigger, then you would have to take the smaller one, the bonds, and add more to it. How much more? 2,000 more. Okay, There's 2,000 more in the funds. The funds is bigger, Z is bigger. 2,000 more than what? 2,000 more than the bonds, Y. So it'd be really easy to flip this just the way it's worded. So just think through this fact right here. Now, if I wanted to solve this with matrix, which I would highly recommend, remember I need to get the numbers together and all the letters together. So I'd move this Y over here and line it all up nice and neat so that I can use my matrices. Okay, so here's my box of neatness. So even though I was kind of thinking through things over here, my box of neatness where it's all ready for my matrix, kind of somewhere off to the side. So then I'd have 1, 1, 1, 15,000. I would have those decimals, 0.04, 0.05, and 0.06 equal to that 730. And then last, be careful the 0 for the X. There weren't any money markets involved in that last statement. -1, +1, 2,000. Punch that in, do your riff, and it should give you this right here. Oops, sorry, got distracted. Where we had 7,000 to make all this work out in the money market, 3,000 in the bonds, and 5,000 in the mutual funds. And now remember, you can take a second and check this work. So when you're on a test, don't just circle and put it, move on. If you have some time before your test is done, check your work. If I added these together, I get 15,000. At least do that. Super fast, super easy. And then I could double check things. 5,000 is 2,000 higher than this one. Okay, the mutual funds were 2,000 more than the bonds. And I could even figure out my interest on all of these. So just be careful. Don't move on too fast. The money markets, the municipal bonds, and the mutual funds. Okay. Also, in word problems, as you've seen in these examples, they tend to come up with pretty answers, pretty numbers. So if you're getting something like 6782.9333333, double check your work. While it is a possible number, it is a possible value, most of the time they create the word problems to give you pretty answers. Not guaranteed, but most of the time. So just double check things if your answers are getting weird. That is all for lesson 4. I know that's a long one, but it's worthwhile. Okay, so just try to take it slow, step at a time, don't panic. You got this. Thanks for watching.